Here we go. Here we go. Here we go. Okay, so real quickly, we're going to talk about inverse trig functions. You all know what inverse trig are, right? Inverse sine, inverse cosine, those are our inverse trig. Of course, we have these other ones. Okay, remember people also refer to these as arc sine of x. That's the same thing. Okay, remember that. We never have, because our book didn't, but just in case you go to college and they say arc sine, we're talking about inverse sine, same idea. And on the AP test as well. Since I don't write it, you may see it on there, but it's the same thing. All right, so when we're talking about inverse functions, how do we do the inverse function of y equals 2x minus 6? Start out real simple. Okay, we switch around the x's and the y's. That's what inverse does. And when we solve for y, we get 2y equals x plus 6, so y equals, okay? And if you want to divide it up, that would be fine, which is called, what do we call the inverse of y? We call it that, right? Okay. All right, how do you graph the inverse? Well, the easiest way to graph it is to do what? If you're graphing y equals 2x minus 6, which is this one right here, what's the easiest way to take this graph and graph the inverse? Yeah, if that's already done, but if it's not already done, take some ordered pairs and do what with them? What are we going to do with these ordered pairs? Flip them x's and y's, and you're going to get like 3, 0 right there, maybe. I'm just, guessing, but okay. And then you graph. And what should the graph look like? What is the visual thing of this inverse? Is it a flip up? Remember? It's a flip over this, y equals x. That's your fold line. You can kind of see it visually once it's up there. It's a really bad line. You actually use my straight line here. Okay. So this is y equals x. If you take it and make that your fold, they cancel each other. Okay? If you take the ordered pairs that are in y equals 2x minus x and flip them around, that's what we talked about. This is y equals x plus 6 over 2. What are some ordered pairs? Yes. Negative 8, negative 1, so on and so forth. Okay? And if you know it's linear, you don't have to have so many. 3 should do it. Okay? All right, so that's linear, just basic inverse functions. Let's talk about what happens when we do inverse tangents. Okay. What is the inverse of inverse? What is the inverse of tangent? I feel kind of dumb asking that question. It's inverse tangent, right? Okay. Nothing to do, but if we wanted to go through the procedure, here's what we would do. X equals tangent y. We do this in pre-calc. And then what would we do to get back y by itself? That's right. Inverse tangent on both sides. Inverse tangent of tangent is y. Right. There we have it. Okay? But we don't have to do that because we know what the inverse is. Just FYI, be careful. 1 over tangent is not inverse tangent. What is 1 over tangent? Cotangent. That's right. A couple of the graduates said their teacher calls cotangent cot. And they were just like, it was Sophie and Charlotte, and they were just like, we were just like cringing. We can't stand it. I said, yeah, because that's a pet peeve of mine. It goes by its right name, but she calls it cot. Anyways. All right. Okay, remember trig inverses of trig functions are not one-to-one functions, I should say. Wow. Okay. So in order for them to be in one-to-one functions, the range is restricted. These are those regular restrictions. Remember the inverse sine function, we're talking about either this one or this one. These are your positive inverse sines. These are your negative inverse sines. These two are doubled. These two are exactly the same as these two, so that's why we count. We do one each. The cosine, why did we do this one and this one?
Because you went into
right, and that would be just a rerun of the first quadrant, right? So these are the positive ones, these are the negative ones, and then tangent back to first and fourth. Okay? And remember how that goes. If you're going into the fourth quadrant, you don't go all the way around. You do this instead. Because you're going to the fourth quadrant. That's why the restrictions are listed like that. Okay? Same restrictions as we did in pre-cal, so that's good. We don't have to switch them. Okay. This is the same idea. This is the inverse. You can't really read it because it kind of disappears, but inverse sine of x equals y, that's the same as sine of y equals x, yada, yada, yada. Okay, so we're just kind of practicing getting into this and notation again, I guess, getting into practice. What's the cosine of the inverse tangent of x? How would we do that? Simplify that expression. Probably not. Actually, we don't have to do that. Let's just go down here and do it easy. That doesn't really serve us any purpose. Yes. Okay, on the exact value of each expression, inverse sine of radical 2 over 2. What is that? 5 over 4. Okay. Now remember, on your summer assignment, you all gave me lots of answers. This one. Okay. Inverse cosine of 1. Ish. Is it 0? Cosine is here or here. Okay. And inverse tangent of the tangent of negative 3 pi over 4. Now, when we do inverse tangent of tangent, usually we get this. And when do we not get this? When do we not get this? Well, that's right, Sarah, when it doesn't fall into our right restrictions. Does that fall into our right restrictions? No. Y is not negative 3 pi over 4, but where is negative 3 pi over 4? You sure? It's in the third quadrant. Okay, so it's in the third quadrant. There's not any of them that we like in the third quadrant, right? So this has a tangent value, which of these two quadrants would have the same tangent value? The first one or the third or the fourth quadrant? Is it negative? This tangent in this third quadrant right here, is this positive or negative? Positive. So where should we be? First quadrant. That is y. You don't want to say it? You're not feeling confident about it?
Oh, not.
Okay. We're all kind of waiting on you. Since you answered the first one.
I said 5 over 49.
Oh, I didn't see your pi over 4. Pi over 4 is the right answer. Okay. We take we know this is pi over 4, right? So we're just transferring this angle here in the right quadrant, so it is pi over 4. Okay? Those have the same tangent value in the first and the third quadrant. All right, so that's pre-cal. We're going to be doing a little manipulation, but not a whole lot. What?
Are you watching this?
No, I Googled trig, and he came up with triglycerides, so that's why. Homer came up with triglycerides, so that's why I switched it to. He also had beer in his hand. But I covered that up. I covered that up with something else. Anyway, those are the next derivatives that you get to memorize in the last one. Okay, so inverse sine, don't forget that's what that really is. If you're looking on your sheet, you're like, where is that one? That's the same as inverse sine. These are exactly the same except for, see the difference?
Cosine is negative.
That's right. And that's the same negative that we have on the cosine. The actual derivative of cosine is negative 2, right?
And the only difference between tangent and cotangent
Is the negative as well. Okay?
oh wait, are all the codes negative?
Yep. So you really only have 3 more to remember. Don't worry about this absolute value bar. If you don't have that, it'll take care of itself. You can just remember it without the absolute value. Okay? So those are them. You have 3 more to remember. Just have to remember the negatives. You know, kind of how they're grouped, I suppose. You have to remember that. So, all right. So let's work with them a little bit here. Same idea. That's the last layer. Okay, y equals inverse cosine of 5x to the 7th. Technically, we should probably have a parenthesis there, just to be clear. Okay, so how are you going to differentiate that? What are you going to use first? The chain rule, okay? Abby, what's my chain?
Inverse cosine of u, and then u equals 5x.
Okay. So y prime. Inverse cosine of u is on that other page. What is it, Allie Grady?
Negative 1 over square root over 1 plus x squared.
Okay, but it's not x, it's
U.
okay, and that's the biggest thing to remember. I don't know why, but I guess because they're harder to remember, you remember them as x. But remember, whatever the variable is, you got to use that variable. Okay, and then what's the derivative of u, Lindsay? X to the what? Okay, and then we got to put in our u, and I'm going to go ahead and just multiply straight across and put in 5x to the 7th, which might be written as what, 25 x to the 14. Okay, so even though it's a pretty straightforward chain rule, there's a lot of potential for mistakes as far as algebra goes. The first one is this one. You'll find yourself putting x there, and then you think you're done with it. Just rolling out x to u. And then the other one is this multiplying that. Okay. Find the equation of the tangent line of y at t equals 1. All right, equation of the tangent line. First one to start with y prime, because that's what? As far as the tangent line goes. M, slope of the tangent line, right. Okay. So, what do you want to do, say, with this? I would. How would you use that?
Inverse sine u as well as t.
Okay. And the derivative of inverse sine is what, Allie Revers? And you said u squared? Good girl. And what's the derivative of 1 minus t, Aaron? Good. Okay, I'm going to multiply straight across. I'm going to get my negative 1, and at the same time, I'm going to put my u back in, which is 1 minus t squared. Okay, that's the slope of the tangent, but we know we're at y t equals 1, so I'm going to plug in t equals 1 now. Okay, negative 1, radical 1 minus 1 squared, that's 0. What's my slope, really? Negative 1. Negative 1 over 1, which is negative. Okay? Well, be careful, but, you know, if you have the thing memorized, it's not really that difficult. All right, I'm looking for equations, so I know my negative 1 goes here. All right. Do I know my y value? No. Okay. So I know my x value is what? Or my t. I should be putting a t in here. And it's really okay if you don't. X and y are pretty much standard equations. 1 is your x, so that goes here. Okay. This would be, what I'm saying is for an equation of a line, it's okay to use x and y. Okay. Instead of, all right, so what, we got to figure out the y. So, we think it's 0?
Yes.
All right, y equals sine inverse of 1 minus 1. The inverse sine of 0?
Oh, wait, pi. Right? Or no, 0. It's 0. Yeah, it's still 0.
Okay.
I'm doing that today. You might say something and you're gonna have it wrong.
Well, I thought you were just being very, I didn't think you really had it figured out yet, so that's why I was questioning it.
Sassy.
No, I didn't mean to be sassy. Yes, Ellen?
And we can make the rag one.
Yes, you can. The term one is 1, so you would know.
I meant on the.
Yes, yes, you can. Okay, any other questions on that problem? Good job. There's your equation of your line. Now, let's take a look at our equation, calculate.
Oh, yeah.
Over here, y equals, clear out what you got here. Put in inverse sine. Remember what that is. You haven't seen that one for a while. That's in blue, second sine. 1 minus, you got to use an x. Okay, and then I'm going to go ahead and put this equation in. So I should put it in as negative 1 parentheses x minus 1. Make sure your mode is in radians because we're back to trig. Graphing, remember just that little tiny bit. And there's the slope. If you want to see a better picture of it, hit trace. And you're probably about right where you should be. And hit zoom in. And then I'll
Keep
give
saying error on mine. Could you do it in, is it in radians?
I bet there's another issue. Go to your mode. Go to your mode and look all the way down here to real. A lot of times it gets switched to A plus PI. I don't
Well, I
know.
just wasn't even, no, that was. And it's just error.
Syntax error. I'm going to go to the error. I know you did. See where it says when it goes to the error, it's not blinking on your -1. I bet you put in the subtraction 1 instead of the negative 1. That's usually what syntax is. Okay? So this little guy, let me, this little blue piece, remember that's the very restricted piece between 0 and pi. Okay? And then that's the inverse sine between 0 and pi. And then that's your tangent at the one piece. So it should make sense when you do that, oh yeah, okay, that's good. All right? I think it's nice to look at a visual, if you can. All right, you want to try this one? Okay, I'll let you try it by yourself first. One. All right, so I put the derivative, now I'm going to put my answer. Negative 2x squared on top of radical 1 minus x squared. Let's see if I'm right. Okay, blue is the function. It's an inverse function, so it'll be fairly short. Okay, red is the derivative. It takes a while for it to graph because it's evaluating all the derivatives at every single point. Okay, and black is what I thought was the derivative, and sure enough, it's the same thing. Okay, so that's how you can check them if you're like, oh my gosh, is that even right? Okay, so let's try it. Y prime. Okay, now I started with the product rule. Anybody else?
You did the product rule? Yeah, I did.
From here. All right, so I'm going to draw out s prime times the derivative, sorry, I'm not saying it right, times s times the derivative of 1 minus s squared plus, what's the derivative of 1 plus cos, or inverse cosine? Okay, good job using the s. I know s is kind of a pain because it looks like a 5, but, okay. All right, now what's the derivative of s with respect to s? 1. All right, this is use of what? Chain. All right, let's see.
How do you just know that? I don't understand how you do that.
Because that is 1 minus x squared to the 1/2. What do you do with that? You can't even do it. You can't do it. It's not like you can square it out. You just can't. Okay, so u to the 1/2, where u is 1 minus x squared. Derivative of u to the 1/2 is 1/2 u to the negative 1/2. Derivative of 1 minus x squared is minus 2x. Okay, here we go. 1/2 u is 1 minus s squared to the negative 1/2 times negative 2s. Okay, plus negative 1 over 1 minus s squared. All right, did we lose anybody? What?
Is it easier to use a square root?
Well, that's a good question. The answer is do either, but do them all the same. So if you're going to go back, if you're going to use a radical here and a radical here, you probably should change that one to a radical. Okay? Does somebody have a question? You're good? Okay. The 2's are going to cancel each other, so I'm going to get rid of those right now. Not messing with them. Okay, so we're going to do radicals or we're going to do exponents?
I'm using
Exponents. Okay. I heard it. I let you, Faye, make the decision. Okay, I got s and s, that's negative s squared, right? And I got, what's the power on that? Negative 1/2. Okay. Did we lose anybody?
I'm copying.
Okay. Now, we got 1 minus s squared all throughout, right? So there's more than likely probably a good chance that we are going to do some simplifying. What I chose to do was simplify with, sorry, common denominator. Could probably do it other ways, but that's what I thought I was going to do because I have two denominators that are exactly the same.
Would you not use 1 over 1 minus s squared to the 1 minus.
No, that's what I was saying. That's what you did, but that's not true. That's why you got yours so simplified, because square root of 1 minus s squared is not 1 minus s. Because 1 minus s squared factors into 1 minus s times 1 plus s. Okay, so I got a denominator here. This is going to stay the same. So far, so good. What's my 1 change into 1 minus s squared? So what do I need right here? 1 minus s squared to the 1/2. 1 minus s squared to the 1/2. I'm just doing a denominator here. So what does this turn into? 1 minus s squared to the 1/2 times 1 minus s squared to the 1/2 is? 1 minus s squared to the 1, which is 1 minus s squared. Okay? Now, at this point, yes, you're like, well, I wouldn't have thought to do that. You could have done something else, and we can talk about that in a minute. So I got 1 minus x squared to the 1/2 on the bottom. There's that radical that you all love to leave on the bottom, right? Now, so what do we got? 1 minus s squared minus 1. That is not 0, by the way. What is it? Which is what? We put in the calculator. Negative 1 and positive 1 cancel. Okay? So, basically, as a general rule, I know it's like, how should I do that? I usually try to simplify my negative powers to be positive powers, because that will usually present a problem that you can simplify quickly and not more concisely. That usually will take care of it. So that's what I did here, and then you get the common denominator deal, and then it ends up being halfway decent. Okay? All right. We got one more page. Derivative of the inverse function. Ugh. Okay, so first I suppose we have to find the inverse function, right? All right, so y equals radical x minus 3, x equals radical y minus 3. Solve for y. What's the first thing you should probably do? Square both sides, so I get x squared equals y minus 3, x squared plus 3 equals y. Right? That's my inverse. And probably have to decide, which one, which x we're going to talk about, because that's not a 1-to-1. I don't think it's going to be a problem. Okay, so what's the derivative of that inverse? 2x plus 3. Okay?
Wait, why is it plus 3?
2x, sorry. You're right, sorry. Okay, I'm on to my next statement already. Now that's an easy one because the equation was easily solved for your y here. Okay, remember this is where your y came. Okay? It's not going to be that easy. Sometimes we'll have circles, sometimes we'll have different equations that are not easily, and so we have to think of a different rule, and that's what's coming next, but we're not doing it today. So,